Alright, so let's start our next chapter, electrochemistry. Let's discuss about the hydrogen economy. Concept is hydrogen as a potential future energy source for transportation. Key characteristics includes simple reaction between hydrogen and oxygen, produces only water as a non-polluting product, significant energy output potential. Electrochemical process converts chemical energy to electricity. Challenges in hydrogen economy. Production challenges. Currently produced via steam reforming for natural gas, also called as grey hydrogen. Not yet independent of fossil fuel production. Expensive to produce. Potential solution can be large scale water electrolysis using surplus electricity from nuclear power, wind power, and solar power. Also, potential production from waste plastic and paper may occur. Now, let's talk about electrolysis fundamentals, electrode reactions. In electrolysis fundamentals, we have first thing electrode reactions. In electrode reactions, we have first thing cathode reactions. So, what are cathode reactions? More reactive metals tend to remain as ions. Hydrogen ions typically accepts electron. Less reactive metals ion readily form metal atoms. Now, ion discharge hierarchy is like this. Positive ion cathode. Discharge likelihood is from left to right. Sodium followed by magnesium, then aluminium, zinc, hydrogen, copper, silver. So, positive ions. In negative ions will be at anode. Discharge likelihood from left to right. SO4 negative 2, NO3 negative, OH negative, chloride, bromide, iodide, all with negative ions. Now let's talk about electrolysis of salt solution. Concentrated versus dilute solution. So in concentrated solution, what happens that produces hydrogen at cathode, produce halogen at anode, halide ions discharge preferentially. In dilute solutions, we have the production of hydrogen at cathode, same like the concentrated one. We produced oxygen at anode when the solution is dilute, and hydroxide ions discharged. Now, electrolysis products table. We have electrolyte, we have cathode, we have anode. So in an NaCl, sodium will be positive, Cl will be minus, potassium bromide, cathode all positive, and anode all negative ions. Now, charge transfer in electrolysis, three-stage process. Number one, electric circuit, which is an external circuit. Here, electrons move through wires. Then powered by battery and DC source. Then we have cation movements. Here positive ions move to cathode, gains electron from external circuit. Next we have anion movement. Here negative ions move to anode, lose electrons, and then it complete charge flow. Now let's talk about electroplating. Definition is important. Process of coating a metal object with another metal layer. Mechanism, it uses electrolysis to transfer metal from one electrode to another. Now let's talk about key electrochemistry principles. So oxidation, loss of electron. Reduction means gains of electron. Electrolysis separates oxidation and reduction processes physically. Now, let's talk about electrode half equations. Negative ions always travel to anode. Positive ions always flow to cathode. Overall reaction found by combining half equations. Now let's talk about practical applications. Industrial chemical production, metal purification. It helps in protective metal coating, and there's a potential future energy solutions. Now let's talk about hydrogen fuel cell consideration. The advantages are it has zero direct emission and has potential renewable energy source. Some challenges includes production cost, storage, transportation, current dependency on fossil fuels. Now let's talk about electroplating techniques. The purpose and application: protective coating is the purpose. It prevents metal corrosion and enhances durability. Aesthetic improvement: it enhances the appearance of metal objects. Some common metals that are used in electroplating are copper, chromium, silver, and tin. Some specific electroplating examples include tin plating, protects steel cans from rusting; chromium plating, resistance to scratching and wear, used on motorcycle parts, door knobs, bath taps, provides attractive and polished finish. Silver plating, applies silver coating to cheaper base metals. Electroplated nickel silver (EPNS) terminology explained. Base metal often nickel silver alloy like copper, zinc, nickel. Now, electroplating basic rules are: object to be plated must be at cathode. Electrode must be a salt solution of the plating metal. So, electrolyte must be a salt solution of the plating metal. Then, anode made of the metal being plated. Now, let's talk about hydrogen as a fuel. So, fuel cell technology, the definition is device converting chemical energy to electrical energy. Now, let's talk about hydrogen fuel advantages. It's non polluting, it has highest energy production per gram, and it's efficient energy conversion. Next, hydrogen powered vehicles advantages are renewable energy potential, lower flammability, zero carbon dioxide emission, and they are non toxic. Next, we have disadvantages: limited hydrogen infrastructure. Currently, we have large fuel tanks are required, technology is expensive, and dependent on energy source of hydrogen production. Now, if we talk about the efficiency, hydrogen fuel cell are 60% efficient as compared to the petrol engine, which provides 35% of efficiency. Now, recommended hydrogen production can be preferred method: solar or wind energy generation, carbon neutral approach, renewable energy sources. Key electrochemistry concepts now: electrolysis, decomposition of ionic compound using electric current. Electrode reactions, here we have negative electrode, which is cathode, metal or hydrogen formation, and positive electrode, which is anode, where there is non-metal formation. Electrolysis process stages: number 1, electron movement in external wires; number 2, electron transfer at electrodes; number 3, ion movement in electrolyte. Some practical applications: metal protection, electric energy generation, and transportation technology. Future potential is public service vehicles, freight transport, sustainable energy solutions. Now, in electrochemistry, let's talk about electrical conductivity. So, conductors versus insulators. Conductors, materials with free electron that can flow through their structure. Metals such as copper, silver, aluminium, metallic alloys, and graphite are the examples. Now let's talk about insulators. They are the materials without free electrons, such as solid covalent nonmetals. Examples: diamond, polyethylene, sulfur. Now, conductivity characteristics. Metals conduct electricity through mobile free electrons. No chemical change. Electrical current does not alter the fundamental structure